Welcome everybody to the OpenUSD Insider Series. We have a fantastic show today with the Wandelbots team. We're going to be diving into robot programming with NOVA and NVIDIA Isaac Sim. Before we get started and introduce everybody, I'm going to go over some quick slides, beginning with this one. We have CES coming up literally just weeks away now. I can't believe how much time is going by so quickly. So it's happening from January 6th to 10th. We have the links for this stream. Anything you're seeing, we're talking about now, we're posting the links. They'll either be in the chat or be on our Discord server. And our producer, Amelia, will be posting that link to the Discord channel we've set up for this live stream with all those resources in just a second. But let us know if you're going to be headed to CES. We have actually a channel dedicated on our Discord server for CES where you can tell us if you're going, if you'd like to meet up, we need help getting introduced to a partner. We are happy to help you. That is coming up January 6th to 10th, and there's going to be a great keynote associated with that, of course. We've released a couple of great articles in the past few weeks. We're going to paste these links also in those resources. How generative AI fuels personalized, brand accurate visuals with OpenUSD. This is super exciting. We've seen a lot of great posts on LinkedIn this week regarding this. Highly recommend you check out these articles to see how people are leveraging generative AI. We also have recently released a couple of great blueprints. This one's for 3D conditioning for precise visual generative AI. And we've got real-time computer-aided engineering digital twins. Of course, digital twins is a big focus of all of our live streams, including for today. So I highly recommend you leverage learning about the blueprints to be able to easily integrate that technology into your workflow. And I think for this slide, actually, I have someone waiting in the wings. Megan, welcome.
Thank you, Edmar. I'm very excited to be here. I'm Megan. I'm from the Omnidocs team. We are responsible for creating and publishing all of the documentation for Omniverse.
Well, I can't thank you and the team enough. The community is leveraging the documentation constantly for learning about all of the existing features and new features. And I want to thank the community also for last year participating in great numbers in our last survey that Megan and the team put together, which was super helpful in helping guide the evolution of the documentation. And Megan's here to kind of talk about this year's survey. So first, actually, was that helpful last year, the feedback you got from everybody?
Absolutely. I want to double up on your thank you. Everything that users told us helped us to improve our docs over the course of this year. We've made some changes. Our homepage is different. We've streamlined the navigation into tabs, and we've also got a new skin. We're focusing on developer docs now. We've got a lot of great API docs out there for people to use. So it was absolutely helpful, and we are requesting your help again to help us find out what else we can do to make the docs better for you over the course of the next year.
That's amazing. And I actually have Megan screen shared on the screen. So we're going to just look at it really quick. And again, the survey only takes about 5 minutes, right?
Yes, yep, should take about 5 minutes. It's at the bottom of the homepage for OmniDocs. So you're sharing the homepage right now. And if you see right in the middle of the bottom, would you mind clicking on that link that says 5-minute survey?
Oh, I can't click on it here, but you can click on it.
I apologize. Yep. There we go. Okay. I got really into this. Awesome. I'm not really going to take the survey because we want to hear from our users, but all you need to do is click that link. It'll load some questions just based on your background, what docs you use, where you'd like to see improvements. And after you submit that data to us, all of it gets consolidated in the beginning of the new year. We review every single comment, we try to find trends, and we work over the course of the next year to make our docs even better before launching the survey again.
That's awesome. Thank you so much, Megan. I hope everybody takes advantage of this opportunity to give feedback to the documentation team to help the documentation better, not only for you, but for the world at large, as they're also digging into these new technologies. We would love your feedback. So thank you so much, Megan, for coming on. Really great to have you. Great to see you again. And we'll probably touch base before the survey closes, which is, how long do they have? About?
January 12th. So about 1 more month.
You only need 5 minutes. So I encourage people to try to take care of it today after the live stream. Don't do it now. Wait till the live stream's over. But that would be great. Okay. Thanks, Megan. Really appreciate it.
Thank you so much, Edmar. Thanks, everyone. Have a good day.
Bye. That was super helpful. Always great to have Megan on to talk about the documentation work. We also have OpenUSD training courses now available through DLI, which is the Deep Learning Institute. We hope everyone takes full advantage of these free courses to help with fundamentals and deeper dives into OpenUSD. Whether you're brand new to OpenUSD or you're a veteran, like the folks we're going to be introducing on the stream in a second, everyone can take something away from the DLI courses on OpenUSD. So without further ado, I want to bring very special guests onto our screen. Let's start with Marwin. Hello, Marwin. How you doing? You're muted, but while he unmutes,
there you go. Sorry. Thanks, Edmar. Like I was already excited, right? That's why I hit this mute button. No, thanks a lot for having us on the show.
Of course, we are super excited. So, so obviously today I give a quick intro that we're going to be talking about robot programming with NOVA and NVIDIA Isaac Sim, and how you guys have actually leveraged this. Tell us a little bit about your role and your background.
Yeah, of course. So yeah, I'm Marvin. I'm with Wandelbots now for almost 2 years, and I'm looking after the partnership with NVIDIA and also looking about the customer engagements and bring them to a successful project and all of this.
Amazing. And I think I have one of your colleagues. We'll warp him in using the latest technology. Here is Christian. Hey, Christian.
Hi, Edmar. Great to have you, and I brought some robots.
I see that. So be careful. let's be nice to the robot. That's great. So tell us a little bit about yourself and your role.
So I'm the CEO of Wandelbots. I'm part of the founding team, have a super technical background, and I'm extremely excited that you have us here in the ground.
We're very honored to have you here, and I see your other colleague, Paul. Hey, Paul, how you doing?
Hey, doing great. Thanks for having us.
Great to have you.
Something small about my background. So I'm a mechanical engineer now with Wandelbots, like 5 years. Started in a lot of project work before I really dived deep into Omniverse stuff in simulation.
And you just shared a few minutes before we went live in our little rehearsal. You're actually a viewer of these live streams regularly. That's pretty awesome.
Yes, so it's really great and exciting to be here. Normally, I'm on the other side of the screen, watching this show for hours.
Well, we are so happy to have you here. And we have your other colleague, Lars, here. Hey, Lars.
Yeah, hi, Lars here. I'm staff engineer at Wandelbots since almost 4 years. Kickstarted together with Paul the integration of NOVA into Isaac Sim.
And thank you so much for coming. And we have a very special guest also from the NVIDIA team, my colleague Lior, who is, we have to thank a lot, because a lot of what happens when you see these collaborations between different companies and NVIDIA and our team are brought about through our DevRel team, our developer relations. And that's Lars, that's your cue to kind of tell us about what you do here.
Hi, Edmar. Super excited to be here as well. I'm also like Lars watching this show and now being on the front. It's really, really exciting. So yes, I'm a DevRel. I'm working with NVIDIA, kind of helping amazing companies like Wandelbots make the best out of our out of our stack. And yeah, that's most what I'm doing here.
Well, we are very excited. So so we have a lot to talk about in this hour, and we want to welcome everybody tuning in. So feel free to use the live chat to ask any questions or post comments. Let us know where you're watching from. That's always exciting to see. And feel free to, if you don't get your question answered right away, don't worry about it. We're putting some stars on these questions. So we're going to circle back to them. If by chance we can hit all the questions, we are going to be continuing the conversation on the Discord server afterwards. We set up a special channel specifically for today's episode, thanks to Amelia, our producer. So we are going to be talking about democratizing advanced robots through accessible simulation, which is pretty exciting. And many people in the community have been leveraging NVIDIA's Isaac Sim for their work in robotics. And as our viewers have known, we have been doing these live streams on robotics. Last week we had Microsoft on, really fantastic. We talked about news from Ignite. So the action continues, and you guys are going to be blown away with what Wandelbots team is going to show off today. There you go. First comment. Awesome support. All right. So now we are going to get right into things. We are going to start with a company introduction about what Wandelbots is, and for that we're going to bring in my gentleman over here. Christian is going to tell us a little about Wandelbots and the history and the mission of the company. I'm also personally curious about where the name came from, if you can squeeze that in at some point. But yeah, tell us a little bit about Wandelbots.
Challenge accepted. So, and I will try to make it brief, since we are all here to see some live action and see Omniverse and Isaac Sim and some robots moving. So Wandelbots is a startup out of Germany, and we work in the industrial robotics space. So what we're actually doing is building technology and providing it to people, so the accessibility of robots gets dramatically better. So I've brought a short presentation to kind of walk you through the major points, and Edmar, if you can start the presentation, that would be awesome. So thanks. So like I've said, we're working in the robotics space. And when we speak about robots at Wandelbots, we speak about more or less stationary robot arms in manufacturing processes. So we are looking at manufacturing sites and provide technology to make that significantly easier. And just as a little bit of motivation for it, right? As you might know, and those data is now from Germany, but it looks pretty similar in the US as well, and in all industrialized countries around the world, is that we do have a significant lack of skilled labor. So robots become a central technology going forward to keep our manufacturing in industrialized nations alive. And even in the current political situation, reshoring and local production becomes more and more important, but we have less skilled workers available in the upcoming years. So automation is a key technology to kind of cope with that. And sad to say, but user interaction, the whole technology landscape in this field looks like this. So we believe that it's time for something significantly new, and software is the biggest driver for that change in the market. So when we speak about software and user interaction and software deployment platforms, what you see in the picture is actually state-of-the-art what you see in today's manufacturing sites. So we believe that with modern technology, so much more is possible in the future. And just to compare this a bit, because many people around the globe think that robotics is a giantly growing business segment. If you compare it to the numbers, for instance, of PCs being installed, it's still a super small Mickey Mouse business, but that's exactly, this chart is the reason why we are doing all of these efforts to kind of help making robots mainstream, significantly increase the number of robot installations first in shop floors, but then in many other aspects on this planet as well. So robotics and automation is currently undergoing a huge change when it comes to softwareization. And software is the part which is driving this change. And Edmar, if you can play the first video, yeah. Let me introduce a product which we have just launched.
Okay, here we go.
Automation today is challenging, and we're here to change that. Welcome to the new era of automation. Introducing Wandelbots NOVA, the world's first fully fledged agnostic robot operating system. NOVA unites multiple devices and IT systems into one seamless platform, giving you more flexibility. Its intuitive interface and built-in apps make robotics automation simpler than ever. Adapt existing setups with digital twins for precise adjustments, reducing downtime without stopping production. Through our partnership with NVIDIA, NOVA expands into the Omniverse for ultra-realistic planning and simulation. Building new applications is now faster and easier than ever. Our developer portal empowers you to create custom apps, extending NOVA to suit your needs. Build advanced web applications with our APIs and WandelScript. Compatible with all major robot brands. We're opening robotics to a new generation of developers and unlocking new markets for you. We're giving you the space to push boundaries and explore the full potential of advanced robot training. The future is here. Join us with Wandelbots NOVA.
Wow, that is super exciting.
Where do we join?
That's great. And I apologize for a little pixelation there. That's because we're streaming from StreamYard. We'll put the original videos in the Discord channel we set for live streams so people can see it in their full glory. But that's pretty amazing. And the fact that it integrates with NVIDIA Isaac Sim, a I want to learn more about how this came about, and kind of tell us what we just saw.
Yeah. So if you quickly switch back to the presentation, what we will be basically are doing with NOVA is it's the world's first robot agnostic operating system. And I worked as a ROS contributor for many, many years. And to all the ROS folks out there, I'm speaking about a fully fledged operating system, which is putting standardization of user interaction and a standardized deployment infrastructure and a standardized way how to interact with robots at the forefront. So we are speaking about a fully fledged operating system. And NOVA has many cool features. So it puts the concept of app center stage. All front ends are based on web technology, so it runs on all different devices. The deployment infrastructure at the back is basically based on Docker and Kubernetes as a deployment platform. So you can run it on your PC, you can run it on tablets, you can run it on servers, even in the cloud. And it's robot agnostic. So it's the same technology across multiple robot brands. And we work with a driver integration system. So basically, each controller integration for us is seen as a driver, and we're partnering here with the robot OEM. So it's not us integrating those robots. We work together with the large robot OEMs to provide a unified experience across all robot brands. So programming one robot works the exact same way as working with a robot from another brand. And basically, besides the pure robot models, we're speaking here not only about the fact that we standardize use of robots, we standardize use of sensors like cameras, laser scanners, the same experience across all tool vendors like grippers, weld guns, and so on, but also equipment like conveyor belts, linear accesses, whatever you have in your cell, and also integration with the cloud provider. And then NOVA provides various software tools across the entire journey, and we will mostly speak about all of them today. So, and those phases, which we call plan, build, and operate, are center stage for us. So it's not only an operating system with an app concept to make the use of robots more easy and more modern. It's about helping folks out there to be useful from the first second on you think about robots. And digital twins, industrial metaverse, and simulation is one of the core components going forward for the entire robotics community to create better results, dramatically lower the cost of integration of robots, but more importantly, to really apply AI, and more specifically also LLMs, so generative AI, into the world of robotics by best-in-class simulation. So when we started our journey as Wandelbots, we needed the best-in-class simulation tool out there that empowers us to really get the best out of the digital twin to really apply it to reality. And we found it with NVIDIA, Omniverse, and Isaac Sim. So thanks for that one. And to make it a bit more tangible, before we go to the Omniverse case, I would like to show you one example on how those easy-to-use interaction looks like in real customer cases. So if you could show the SHL video, for instance, I can make it very tangible.
I would love that. Okay, so here we go.
So I'm a scientist at the Excellence Cluster Physics of Life at TU Dresden. We're here at the Max Planck Institute for Molecular Cell Biology and Genetics.
Oh, yes.
That's a
Is that the wrong video?
Yes,
No,
that's
that's the AI video, which we
Oh, I see. Sorry. Video number 2.
So
I got it.
video number.
Here we go.
But don't worry,
that was a tease. That was a tease for everybody about what's to come. So here's a little Men in Black. You did not see that. Okay, here we go. Video number 2.
All right, so what you see here is a typical sanding application. So we're speaking about a robot sanding a workpiece, which traditionally is super complicated to program. Here, there's a camera mounted on the robot, scanning the workpiece, and then you switch to an app where you get a 3D model, a digital twin of the workpiece being scanned by the robot. You just select surfaces and edges, adjust some sanding specific parameters, and then the software automatically creates the entire robot program. And that's a solution which enables a carpenter to teach a robot to send a workpiece, which within less than 10 minutes, which traditionally takes a skilled robot programmer to only be done in maybe a week or two if we are also speaking about more complex setups. And that's one of the examples on how software really lowers the barrier of entries for companies to use robots in their facilities independent of on the company size. And that is only possible if we have the best digital twins available, because that works. In reality, at the end, it's very impressive, but in order to get there, it's a long process, and precise digital twins make this process significantly shorter. And now, two of the best guys in the company when it comes to the industrial metaverse, Paul and Lars, will now walk you how we do that and how this looks like with our customers in reality.
Awesome. Well, thank you. I mean, it's amazing how you're able to bring physics-based simulation to all skill levels in the way you have. Pretty amazing. Got some great comments coming in the chat. So feel free to keep posting your questions and comments. And let me see, I think we're going to switch it over to Paul, right? And Lars. Okay, so let me see. So Lars, should I share your screen?
I would hand over to Marvin first for the partnership with Leo, and then we go into the presentation.
Okay, got you. Okay, so we are going to switch it over to Marvin and Lior, and we'll talk about how, because you guys are a member of Inception, correct?
Exactly. A proud member of Inception.
There's probably a lot of startups that are watching this live stream right now. I would love to learn how you guys got started with Inception, why it's been helpful to you. And yeah, exactly how this partnership with NVIDIA started to come about. And for that, Marvin and Lior.
So maybe just give some insights how we started working with Inception also. And as Christian already mentioned, in our DNA was, hey, we want to democratize robotics and we want to have an open platform to work with. We came quite across like Isaac Sim and wanted to start with this, and we became an Inception member. And it was a great experience so far from us, from the beginning till now as well. Lior, as my counterpart, like we can always reach out to, who also supports us on various cases, not just on the technology, but also on business cases. And that's why I love this also relationship with NVIDIA and with you guys.
Yeah, and I mean, from our side, from my side, I think it's really amazing to see how companies like Wandelbots and as a developer, I work with many companies, Inception members, and also enterprises. It's really amazing to me how OpenUSD and Isaac Sim enables companies like that to create such complicated products and such complex tasks in fairly short amount of time. And I think this is thanks to I mean, as Christian said, that vision of digital twins, it is being enabled via OpenUSD and via applications like Isaac Sim. So I mean, maybe Marvin, because you're the ones who are actually touching the stuff, like maybe you can say in a bit like how stuff like OpenUSD kind of accelerates your vision.
Yeah. Course, yeah, and what I touched on, like for us and our DNA is we want to drive openness, right? Openness that people can work with robots from all different kinds, and that's why OpenUSD and also Isaac Sim, as I see it, like as an open platform, it really provides you with this openness with connectors that also help customers, for example, that they have built maybe already libraries in different other solutions, for example, process simulate, visual components, that these things not getting lost, but having Omniverse and Isaac Sim as an overlaying layer. And you can just connect to it and actually have these still there, bring it to the next layer where you can also add physics and add the perfect solution with NOVA to bring robotics there in as well. I think that's a perfect match that we saw, why we want to work with OpenUSD and Isaac Sim and see a great collaboration there, because we can bring it into the simulation with NOVA, but at the end, we can also bring it to the shop floor, to the physical robots. And Isaac Sim brings in a reliable simulation in this one, especially with
I think even coming up next, I'm not sure how much is going to be exposed, but the fact that because AI is coming next to robotics, right? So the fact that we can integrate perception inside of this stack is really going to unlock so much opportunities for many others, and even inside the Wandelbots platform. And on top of that, even reinforcement learning using Isaac Lab, which I think is also coming up on your guys' pipeline. which is really amazing. And it's great that all of that is being enabled through the openness of OpenUSD and the open platform.
Exactly. It's easy to build up on it, and that's what we like.
It was important for me to us to kind of talk a bit high level of like why OpenUSD is important, because soon the guys are going to jump right into the stuff. So, you know, wanted to kind of align.
Yeah.
That's awesome. That's great. Super valuable. And again, for these people who are not familiar with Inception, you could just go to the Inception website and very easy sign up process. And you have nothing to lose, really. And the requirements are actually pretty flexible. Your startup just has to be between 1 and 10 years old. So it's not like if you were a few years ago, you can't join Inception. So lots of great free benefits there: cloud credits, resources, collaborative marketing, networking events at events like GTC. So anyway, so lots of great reasons to be an Inception member. And here's one great result you're seeing with the Wandelbots team. Okay, cool. And I think we are going to do a deep dive now. I jumped the gun a little earlier because I was so excited, but now we're going to have Paul and Lars, I think, dive into it a little bit. So all the engineers watching, we're going to take a deeper look on how some of this work is actually done. And I think now I can share Lars' screen. Is that okay?
Yeah.
Okay, so I'm going to share Lars' screen, and I'm going to move some of us just so we can see you guys a little better here. There you go, and I'll take myself out.
All right, thank you. So as Kristen mentioned, we are building a platform, and for every good platform, we also provide a developer portal. So that is our entry point. When you are listed, you can log in. And for the simulation part, we will use our cloud instances. And we are just creating one so that we can dive into it. It will take some seconds until it's up and running. And for the Omniverse integration, we have a token which you need for the API access. And there it is. We have this instance running. It's now populating the required services. And we are a robotic startup. That means let's create a robot. We can do virtual and physical robots. We will use the virtual robot, and we use the FANUC for the setup case, which Paul will go into later. And after that, we are ready to go into our Teach pendant, which is the entry door for connecting to Omniverse. And here you can see it's our simple 3D visualization. When you're on the physical robot or just want to try it out, you can classically jog the robot around. You can program it and so on. And there's our description language, which is based on Python. It's Wanderscript. This is important to mention because we ripped out everything which is complicated from Python and focused it on the robotics domain. And you will see later on what powerful things it provides. And there we created a new program. And as every program starts with the Hello World program, and now we will just create some movements. For that, I'm going back into the jogging interface because we make it quite easy to teach poses. For that, I'm just moving the robot around a bit. And then we have a poses storing feature, which allows us to save those keyframes. And if this is done, we can then automatically use this in the Wanderscript. And here's my first pose, and I will now move the robot around a bit again so that I can show you some simple Wanderscript. So there's the second one. And now let's just write some Wanderscript. So you can see that you automatically get the information from the poses list. And then we will just move the robot to the first point and then to the second point. And let's see how it dances. So we have different move commands like point-to-point, line movement, arc movement. You can use the different ones to create a complex program. Paul will show you a really sophisticated program later on. And there you can see it moves. And we can also classically do joint movement to also teach joint poses, because sometimes it's important to have a dedicated joint movement so that the robot is really in this position, because if you just have a pose, sometimes the robot can also move from bottom up, and to avoid that, you can also just use joint movements. There it is. And then we now have 3 movement commands. All right, so the next thing is, as we are at NVIDIA Omniverse live stream, so it's not going without Isaac Sim, so let's get started. As I mentioned, currently we are using the launcher. It's gone next year, but to say goodbye, we will use that for this stream. So we have we have a download section at our developer portal. There you have this Isaac Sim extension which you can download and link with the Isaac Sim. Then we have also provided an asset starter package, especially important for the robots, because each individual 3D model you can see is provided by us to ensure that it's accurate with the physical counterparts, because we also want to provide our users so that they can simulate and then directly go into the operation mode without any adjustments necessary. So we downloaded already the asset pack here for preparation, and we can just move the robot into the scene, and then we will show you that it's that simple to connect the robot with our Wandelbots NOVA. There it is. Now I'm going back to the robot pad to show you how the connection is working. So you can see the green button on the bottom, and there it's running on the same system. You remember we have the token. We will just take it back, copy it over for authentication because it's a cloud instance. And after entering it, we will then automatically connect it. And you can see the FunHook is on the NOVA system available, and we will connect it now to Isaac Sim. You can see that the prim path is automatically detected because we are searching for the articulation. And then we can just connect it. And if it's connected, we can then see in Isaac Sim that it took over the pose of the NOVA robot. And now we can also use the commands for jogging, programming, and so on for the Isaac Sim counterpart as well. Let me make it a bit bigger. So, and now let's get rid of this 3D view of the Wandel script, and let's move the robot a bit. So, and after that, I guess I can hand over to you, Paul, so that we have some scene building to present to our audience.
Sure. Thanks, Lars. So now you've seen how we connect a robot to Isaac Sim, and now I want to show you how to build a complete scene. So first we take some assets from the NVIDIA library, preparing the environment, and we load our assets. These come from our portal. We load these into the stage tree. just dragging and dropping all these objects here. I like to create this cell X form where I put the robot and all the periphery. Like this, we have one cell in the end that we can move anywhere, that we can export, import into another scene, stuff like that. And now we imported the tool, and we want to attach this tool to our flange, of course. So we copy the translation or the transformation from the TCP. This TCP is already stored in the FANUC 3D model in our USD assets. And now I'm just doing some small adjustments here to this tool. So great, this is now attached to the flange. And when we play this simulation now, there's something missing, I guess. Yeah. So this tool is now falling down because we have not really attached it yet. And to do so, we have to look for the body prim of our tool and attach it with a fixed joint to our last link of the robot. Once we've done that, you will see this tool not falling down anymore. And by that, we are good to go. And we can start setting up the NOVA site for this specific gripper. Here you can see also in our tool USD files, we've stored the TCP information already. And now we want to apply this TCP information to our NOVA robot. To do this, we enter the API and we search for the available TCPs of our robot. And after that, we just copy and paste it. We give it a new name. I call it gripper here. And you can see that this Z value here of 160 millimeters is the same as in our USD file. And yeah, we apply this, reload the page, and now we have the gripper TCP available. And you can see that the gizmo changed in our 3D view here. And when I'm switching to tool orientation, you can now also see that this red, green, and blue arrow are facing the same direction as in Omniverse, in Isaac Sim. To see this, we have to connect. And now we can see that the TCPs are perfectly aligned, and we are good to go to start teaching with this tool. No, we are not. We have to set up something more.
I'm sorry.
No problem. I was a little bit quick here. So we've set up the TCP, but we've actually not set the articulation yet. So I hope we can start there. No, that's too far. Yeah, here we go. Perfect. So we copy the prim path of our tool. And now we look for the IOs we are using to use this tool. So we are using digital out 1 and 2. We are setting the limits of our linear drives, and now we are creating the states. So here we have an open and a closed state. You can also define states for every amount of movement you want to do in between. But you should be aware that this also has to be available on the physical tool in the end, because that's what we want to, this is what we want to build here. Now we're starting to write some code. We start with a gripper function, with the open gripper function, and we are just writing true and false to these two IOs we defined before. After that, just as it is, just you're used to from Python, we can use these functions. Okay, I have to correct some stuff here because of the copy-paste. And we are also adding some wait commands, so we can see the movement of the gripper fingers. All right, let's zoom in a little bit and hit play. And you can see nothing's moving. This is because there still have to be some adjustments. We're using digital out 1 and 2. Now, yeah, now you can see this gripper moving. Great, so now you're actually ready to go to use this gripper inside Isaac Sim. It's just as easy as that. But we are actually also working right now on making it more, even easier by collecting the data of the gripper automatically from the USD files, right? And just to mention OpenUSD again, it's just awesome that we can collect all this data and create our programs, our robot programs from this 3D data. So we just loaded our workpiece into the scene, and you can see it falling through the table. We have some missing collision meshes here, so we just add a default collider. And by that, this workpiece should now stay on the table when we play simulation. Yes. Great, and as I said, we want to extract the data from USD and use it in our robot programs, right? And to do this, we have another set of APIs. We call it Omniservice API. Here we go, and you can see that there's scene, configuration, object categories. So this is all the data you can get or you can manipulate from or inside the Isaac Sim USD scene. So again, we are just copying the prim path here, and what we get back from this API endpoint is a pose, and this is a Wandelscript pose we can directly use in our robot program. So let's write cube pose is this pose we just extracted. And then, as Lars has showed before, we start our execution of this program. Besides the cube pose, we need some adjustments of this pose, and these adjustments, they can be made very simple inside Wandelscript. You can see the object here and our workpiece. It already comes with different picking positions. We've added these also to our USD files, and these values, these are now relative poses, and we want to add these poses on top of our object pose, because depending on if we want to grab our object from the top, from the side, or whatever, we want to adjust this Wandelscript pose there. So we are adding the grip pose by just typing double point, and we add the definition of this pose here. Now, and you can see these are already prepared in this workpiece USD. Right, and now what we want to add now is another relative pose, and this is an approach pose. So we do not want to go directly with a P2P movement to the gripping position. We want to approach the workpiece in a line movement. That's why I'm also adding this approach movement here, or this approach pose. And we're just traveling a distance of 50 millimeters in Z direction. And now the next movement, of course, has to be a line movement. We copy this gripping pose here again, paste it, and maybe, I think at this moment the doorbell rang, so let's wait for the rest of this code here. When we add that pose, we want to close the gripper, and in the beginning of our execution script, we want to open the gripper, of course, because we do not really know the state of the gripper at that point. So let's just be make sure that the gripper is opened when we approach the workpiece. Also in the gripper functions up here, I'm just adding a sync and a wait. And this is only to make sure that we have the workpiece actually grip before the robot starts moving again.
Yeah, in the future, we will also extend that we have the input signal coming back to us so that we don't have to do that in the virtual space. Because on the physical space, we definitely have this input signals to react to. At the moment, it's not available, but in the future release, definitely.
Yeah. Just to keep the code clean and a good overview, we are adding some comments here. Normally, I'm always starting with the functions. After that, I introduce all the poses of the skill. And you see that this last part, the execution, is only a little bit of script when everything is prepared well. So after we grip this workpiece, we want to go back to the approach position. We have to switch these lines here. And then we want to open the gripper again to drop the workpiece again. That's it. Now let's connect to Isaac Sim. We can see the robot going into its initial pose. And yeah, well, this is why we love simulation. In the real world, we would now have crashed the robot. In the simulation, this is all safe. And we know the reason why we did this. Actually, I did not define the gripper TCP for this movement. So yeah, I made a little cut in the video right here. Now we are actually using the gripper TCP, not the flange TCP anymore. But there's another small issue. That was the collision meshes. So we switched the collision meshes from triangle to SDF. And now you can see we have some really nice gripping. And this is all looking good.
All right, then let's show some advanced stuff.
That's how you build a pick-and-place application from scratch with our library. And now we brought a little bit more complex cell here. So let's just open this USD file. This is a demonstrator from our last fair, from the SPS, where we are using 4 industrial robots from 4 different manufacturers. And we introduced you to how we configure our tools. You can, of course, export this configuration and import it again. So now we can see all these 4 robots are connected. And yeah, this is a nice feature we just developed. We call it ghost teaching. Ghost teaching means that you can have an object. It might be a tool or a workpiece. And this object comes from the USD file. And we are constantly reading its position and directly convert it into robot poses. So you can see I can drag and drop and rotate this 3D object in our Isaac Sim scene. And after that, directly move to that position. So for us, this is really the fastest and easiest way to generate robot poses. And it's very handy to make some reachability studies to check if the robot you chose is the right for your application and all sorts of stuff. Yeah, you can try out really, really fast here.
And the good point is here, we only rely on naming conventions. So if you name your tool, which is attached to the robot, it automatically detects it. You can see also four more objects. And we auto-generate them. So it's no preparation from your side, only the naming needs to be put in and the tool needs to have an TCP. And then you can drag it around and also see that it's outside of the workspace and it sends you the signal that it's not reachable.
Yeah. So all our assets, of course, come ready to use, but we also offer the documentation so you can build your own tools on top of it. And now we loaded the Wandel script, and this is, I think this is pretty amazing because this is only one Wandel script controlling all 4 robots, all the tools, and yeah, it's also manipulating the Omniverse scene in between. So, for example, you can see this light going on and off. We had to speed this up because the robots were moving super slow because it was a fair and because of safety reasons. We had to set the speed to very, very low. That's why we had to speed up this video here. Yeah, and also maybe if you wonder why this program is like 1,000 lines long, in this program here, we not only have the movements of the robots, but also all the logic, because on our fair, we had 3 different interfaces where the visitors could manipulate these movements and the order of these movements. So we always had to check the state of all robots and what's possible, what's not possible, and how we execute the commands. So this is all handled by one Wandel script only. Yeah. And this is how you use multi-robots.
And here you can see the physical counterpart, Paul in the front, Omniverse in the middle, and in the back the physical. And here you can see that we set up the scene and the physical one so that you can see a direct comparison. And here you can see on the right side it's Omniverse scene, on the left side it's the real world, it's in sync, it's connected at the same time. And it's just amazing what's possible with NVIDIA Omniverse and with Wandelbots NOVA. And that's how we do our daily business. Just program the robots in one script and let them run. And that's how we did it on our launch event. Maybe, Paul, you can say something to this because you did the programming in the background.
Yeah, so for us, this really came in handy because we did not have all the robots available until maybe 1 or 2 or 3 weeks before the fair was starting. So we basically planned the whole booth inside Isaac Sim. We did all the programming. Yeah, basically we did all the simulation before we even started putting the physical demonstrator together.
Yeah.
And in the end, it was super easy because we defined a few calibration poses. So we just had to go into these calibration poses. And like that, we were able to make sure that each of these robots is actually mounted in the exactly correct space and that these handovers work well and all that stuff. So yeah, Omniverse brought a huge value here to the whole process. Also, when it comes to communication, because we were able to discuss everything beforehand with our marketing team. How is it gonna look when it's standing on the fair? And yeah, here you can see it in action on our launch event. One fun little detail here, you can see the video playing on the screens. This is actually not a video, this is a live stream of the cell. And we also added some camera movements. Actually, I don't know how to do camera movements inside Isaac Sim, so we just attached the camera to a big robot and let it run in parallel. So maybe if you can play this again. because it just stopped.
This is so awesome.
Yeah, so you can see the 4 robots moving synchron to the animation in the top. And all these camera movements, they are also done with a invisible robot holding a camera.
A 10 times scaled robot, yeah.
Amazing. Really, I mean, I've been sharing some of the comments on the screen that are coming in, but people are kind of blown away how simplified you've made the process. I saw the logo on one of your assets earlier, that everyone can work with robots. I think you guys are really proving that to be the case. Really, really impressive work.
Yeah, and it's absolutely awesome. For me, coming from a mechanical engineering background, all my work, it was always static. But when I started with Isaac Sim and Omniverse, suddenly all my 3D files got dynamic, and I could just manipulate everything. It's pretty awesome.
Yeah, I'm currently showing also our next endeavor. It's the integration of the viewport of the Isaac Sim and directly in our robot pad, because we you saw in the past when Paul was talking, we had this split screen. So on the left side, the window of Isaac Sim, on the right side, our web browser, and it's just not that convenient for our customers. And that's why, with the help of NVIDIA, we now have the viewport also integrated, especially for the ghost teaching Paul mentioned. It's just easier to use it because it's only one window, not multiple windows, and you can just move your cursor on the left side without pressing anything. It's just taking the mouse over. You can move it along, and it's getting easier and easier. It's just amazing what's possible at the moment.
It's absolutely amazing. Paul, I'm afraid to say you've got a fan club brewing, unless this is your mom or dad.
Hey, Mom.
Absolutely amazing. I'm gonna bring some of the other team back up here. This is really fantastic. Let me see who else we got here. Okay, I think that's everybody who's in the wings. Really, really fantastic. Blown away, actually.
It is one of the best demonstrations of like a digital twin, coming to life. And I just think of what's possible with this,
Absolutely blown away. We've got a bunch of questions coming in, but I also know that we also have a really cool customer story video as well. So if you guys are okay, we can go a little bit over, because I don't want to stop the party yet.
I think we're fine, but what about the audience?
Oh, the audience! Look, our numbers keep going up of viewers. We're hundreds of people watching right now. Actually, I've been seeing, because we've been sharing resources on the Discord server, and I'm getting all these pop-ups and people are joining the Discord server. So you're building a great excitement here.
And we will keep up with the questions when you just keep coming with the questions, and we will keep answering them also afterwards.
Okay, great.
Answer them.
Amazing.
So just in the background, I'm showing that we this robot, which is in the background of Christian at the beginning, we have this simulated. We create an app. You can see here the app so that it's easier for the customer to palletize and create pallets. And for the worker, which is on site on the pallet, he can or she can just use this application, define the pallets, simulate the paths, and then just execute it. In our shop floor behind Christian, we just let it run 24 hours for long time testing and so on. And there you can see it on the customer side, fully fledged, physically with our web application mounted with Nova running, and it's just doing what the worker was teaching. And here you can see Christian back in the background. There's the robot with the app just running.
There it is.
So, and here I just want to show one feature, because we talked about AI, about advanced features. We have this sending application. So you can see here a robot mounted on the ceiling, and we had to run to the customer multiple times because the robot was not able to reach the workpiece from all sides. And that's why we tried out Isaac Sim, because we have APIs for cameras and LiDAR scanning and so on. So here you can see the Isaac Sim digital twin ceiling mounted FANUC with the camera attached, with the tool attached. And we just use our application, which was especially built for this application. And you can see we scan the object. This is now the camera from the end effector directly. And then on the application, you can see it's processing. And if it's ready, it scans the object and puts it into the application. Here you can see the digital twin of the workpiece. And we automatically, when the user is selecting the surfaces and edges, it's automatically generating the paths based off the work of the 3D data. Here you can see there's a line which represents the movement from top to the workpiece and then meandering. And here you can see we just play the application, and on the left side, it's just using the input data from the application and it's running. And we were able to, with ease, within 1 week, I'm not sure enough how long it took, but definitely less than going to the customer every week, mounting and remounting the robot. And we were able to just find the perfect position for the robot.
And I would like to put emphasis on the fact that, of course, there are gazillions of simulation tools out there for industrial processes, but there is, to the best of my knowledge, none in where you can actually simulate and test the entire stack of such a sensor-based application. So taking everything from start to the beginning, including cameras, including virtual workpieces, so virtual scanners creating virtual point clouds, which are actually then processed with virtual robots and tools. You can actually, and that's the beauty of the entire platform, Omniverse and Isaac Sim, is actually that everyone can integrate their parts, so you can create not only an ugly digital uncle, but really a digital twin of what's happening in reality.
Absolutely, I think this is so fantastic, and thank you for sharing all this brilliant information and making this available to people. We do have a bunch of questions. So would you like to play the great customer story first and then tackle some of these questions? That makes sense?
Sure.
Okay.
So
I think
we brought a couple of examples, so you can just share them.
Awesome. Okay, so let me take a look. We're going to play this video, and I feel like obviously it's great to see this in action by your team, but even better when you get to see a customer in the wild working with your technology. And that's what we're going to take a look at right now. So this is a really compelling use case showing work with the team and with NVIDIA Omniverse. Here we go.
So I'm a scientist at the Excellence Cluster Physics of Life at TU Dresden. We're here at the Max Planck Institute for Molecular Cell Biology and Genetics. And I'm a biophysicist. The Excellence Cluster Physics of Life is aimed at understanding structure formation and dynamics inside living systems. And for that, we need to perform accurate physical measurements inside living systems, which often implies the need of generating large data sets under reproducible conditions. And this is exactly where we are excited about the collaboration with the second excellence cluster of TU Dresden CETI, but also, of course, with Wandelbot, to use robots, to use robotics as a novel way to automate the lab environment, to allow us to pursue experiments we can't do at the moment. So we've had a fantastic experience with you guys. I was impressed how you took us through this initial idea of having a device, a robotic device that can help us automate, that is flexible in the lab environment. I was impressed with your three-tiered approach to first build this in a virtual environment in the Omniverse setting, which, as I've already alluded to before, really allows us to place this robot flexibly in different workflows inside the lab. You'd first set this up in Omniverse, and then once it's set up in that particular environment, interfacing with the microfluidics of this microscope, you can then talk to it and make it do the experiment in a repetitive fashion.
Hey Pipette Bot, make me buffer C.
and then the execution of it, to have it sit there. I was impressed in particular by the fact that, you know, once you've set it up in Omniverse, it just operates in the real world just as it operated in Omniverse. And you can use a large language model as we've used it in Omniverse now in the real environment. And, you know, instead of spending time pipetting, you can then do data analysis while the robot does the experiments for you.
Amazing! What a great story. And I think Lars, you even have some more. So while Lars brings that up, we're going to take some questions that have been users have been patiently waiting for. So let's see. So we'll try to do a lightning round on some of these. So feel free to answer them quickly, and then we can tell people more details. Will be available on the Discord server afterwards. Okay, so here we go. Let's start at the beginning. Here we go. Will Wandelbots OS allow third-party apps, add-ons, integrations?
Yes, that's what it's all about. So, of course, a modern operating system without the possibility to extend it is worth nothing. So it's all about enabling people to build their own apps. So we truly believe that no company on the planet would be able to solve it all. So what we're basically providing is to give out tools to people to create stuff we wouldn't even be able to come up with. So that's the whole essence and idea of what we're doing.
Amazing. Okay, great. Thank you. Well, okay, I can kind of answer this throughout, but I'll throw it on a screen anyway. Is it good for simulation? Yes. I think that's what it's all about. Okay, here we go. Here's a question from Shane Reitz, who's a fantastic community member. People have been watching him answer some great questions and ask questions and post comments live. Here's his question. Does the 3D view in the browser use kit streaming with WebRTC, or is it a separate visualization tool?
No, it's exactly the WebRTC, which is provided by the kit application, yeah. Great.
Another great application of kit in Omniverse. Let me see. Here's a great question. Let me see. It's not showing. I have to read it out loud. It's not showing for some reason. Is it possible to get demo access to Wandelbots NOVA? There we go.
In principle, yes. So we currently, so general availability of NOVA will be somewhere in spring 25. However, and currently we're in a phase of, we call that limited availability. So we work together with companies or individual developers. We have some criteria attached to it. So it must be meaningful. It must be relevant for us and for the party. But reach out to us and let's have a conversation about it.
Amazing. That's great. Okay, Amelia, just a note to you on the back end. It's not letting me click on the start question so quickly. So let me see. It looks like it's delayed. I guess it's a similar answer here. Can we access the Wandelbots API docs?
Of course.
There you go. Right,
the general idea also in Wandelbots is we want to be as open as possible to everyone. So that's the whole idea of documenting everything, making APIs available. There is nothing we want to hide from you. So that's, yeah.
Okay,
absolutely.
Awesome. We also integrate extensions with extensions, simulate real world scenarios. So yeah, this is, yes. I knew that myself. Okay, let me see. Here's a good question from Pear. We have a robot that's using vision camera mounted on the robot arm. Do you support vision processing and robot movement simultaneously?
As you can see in the last video, we showed it.
Yeah,
it's possible.
So thanks for that great question. From Renan, who's another great member of the community. How can we deploy a robot that leverages an AI interface to do tasks like two-hand manipulation using your tool?
That's what the Paul application in the last video was representing. We had a hand-eye calibration task. You just put the board on the table, and then you can have a calibration with it.
Fantastic.
And Edmar, let me add one thing to it, right? So right now, especially advanced robotics is all about applying AI to real-world robotics. Why this was very hard, near to impossible in the past, and all attempts failed, was lack of data. So no one in the industry has enough data to train models which are good enough to be applied in reality, and it's super expensive to generate the data. Simulation environments were too poor, so the virtualization gap was too large to simulate in the virtual space. And now this is changing. So we bring in WandelScript as a language, which is a good foundation for LLMs to train on. But with the technology you guys provide, plus our ability to have virtual robots which behave in the exact same way as real ones, we are now have closed this virtualization gap to an extent that you can train in the virtual world and apply it to the real world. And that's, I think, is a real game changer.
Absolutely. That's fantastic. From GT213, how do you send commands to the robots? Well, we kind of went over that a little earlier. So just back up in this video and hit play, and your answer is right there. Okay, we're gonna hide that one. Here's another one from Shane. Wonder how far away they are from integrating different live stream sources like EGM. Is that familiar to you guys? Shane, a little bit more context there, so feel free to post that as a follow-up, and we'll try to circle back. Otherwise, we'll touch base on the Discord server. Let me see. Here's a question from John. How do you calibrate the joint drive characteristics in Isaac Sim to real-world robots? Can you somehow match the motor characteristics and control values of different robots?
Yeah, so that's part, I have to admit, that's part of our secret sauce. So there's a little bit of work. So we invested the last 6 years to achieve exactly that. And that's one of the major challenges, nuts we had to crack. And this is not only like static data, we even are able to simulate robots also from their dynamic behavior. So if you have 50 kilo loads on a robot, it will behave different than without the load. And simulating those characteristics also from motors and drives is what we have spent so much effort with. And I can say that we integrate robot models with a driver, and that driver encapsulates all the knowledge about the individual behavior of motors and drives. We also open this up for people to integrate with their own robots if they have one, but how we did the work in the past for the robot brands you were just seeing, that's part of the secret sauce.
Well, another great reason to work with you guys. Here's another question from Shane. We might have covered this earlier. Does Nova use robot controller simulation? I see Lars, yes.
Yeah.
Okay, cool. There you go.
So we have virtual controller and you have physical controller, and they are running on Nova.
Okay, another follow-up from GT213. How do you deal with singularities? Does software recognize them and adjust the path automatically?
Yep. So part of path planning. So we do have things like singularity path planning, collision-free path planning. Those are all features on top of Nova.
Okay, great. Here's one coming from LinkedIn. Do you plan to use the camera to train the software to detect defects and direct the robot to perform rework like sanding?
So we don't, but our customers do. So that's exactly the point. We provide tools to help companies build those amazing stuff. So the sanding, video, palletizing, those is all not applications we have built, but they are built by our partners which are using the technology. So if you are, whoever asked that question, if you're interested in that, if you're from a sanding expert company, just use the tools and build it yourself, or go to your favorite system integrator, show them Nova and ask them to build it for you.
Amazing. Okay, so Shane actually was quick on the ball and did a follow-up for that EGM. EGM is a way to communicate with ABB robots. It's externally guided motion. For instance, you could generate a path and be streaming joint or TCP targets to a robot rather than PTP moves.
So like I said, I will not go into detail on how we do the individual integrations with the robot models, because that's the only one of the few parts which we consider secret sauce. So basically how we integrate with a robot controller is very individually. We partner there with the robot manufacturers, and we might not always use the official documented ways. Sometimes there are better ways to do it. And yeah.
Okay, perfect. And well, I got to show something from Twitch. There you go. Hi.
Hi.
Good old Twitch. All right, very cool. This has been fantastic. I think we actually have some really cool stuff. Lars, is it okay if I share your screen? Okay.
Yeah, let's do that.
Let's take a look at this.
And Christian, I think you can.
Yeah, yes. So what you see here is so one of the use cases we have done in the past. So one of our customers also Volkswagen, so giant German automaker, and here the challenge was to basically train a robot do horn assembly. So the part which is making the honk sound in the car, which is currently assembled manually, they wanted to automate. So it was all about picking objects. When you design those types of applications, complexity is designing the right fingers for the grippers. Devil is in the details with the process. We had cameras for detecting the position of the objects and all of that. So it looks very simple, but designing it takes typically a couple of months until it runs stably. What we did here is try to build everything completely virtually before we do the first physical test, and only do a virtual commissioning for the entire application, including object detection, gripper finger design, and all of that. And we were able to build a digital twin in Omniverse first, do virtual commissioning, and then apply it to the real world. And the overall project was done in a fraction of the time it typically takes, because all of the mistakes you typically do in such a project, you could do virtually, which only takes you a day rather than a week.
Really, really compelling. That's fantastic. And again, I think we're going to continue this conversation on the Discord channel we set up. So feel free to hop on over there and jump into that channel we set up for today.
Yeah, and maybe another very different use case, which was more brownfield. So what you see here is a physical cell of one of our customers, German automotive supplier. Their challenge was that cycle time for producing parts was twice as long as planned. With the physical setup, it was a nightmare for them to optimize for cycle times. And that's a problem many companies have. So what they did was using Omniverse to create a digital twin of the cell, do all the optimization of cycle times, also partially automatic in the virtual space, and then reapply it to the real world. And here, the company was able to reduce the overall cycle time from a bit more than 23 seconds to about 12 seconds in just 5 days of work. And we speak about hundreds of thousands of parts being produced more with such a small adjustments enabled by NOVA and in combination with Omniverse.
Really fascinating. And we have a great maybe final question here from Process Robotics, put on the screen. Where does Wandelbots OS run? A standalone host? Would there be one Wandelbots OS instance for many robots, or one per robot?
Great question. So basically, it can be deployed on all various devices. So you can deploy it on an industrial PC, on your laptop, in a cloud environment, even edge cloud. So we partner here heavily also with companies like Microsoft. And in theory, you're able to control as many robots in parallel as you want from one NOVA instance. But what customers typically do is to use one NOVA instance for a cell. So one cell, one NOVA instance.
Okay, that is a great question, and amazing story all around. Lars, that's it for your screen, right? Okay, cool. Oh, hey, this right here. Here you go. Let's get in touch. There's a website, and as Christian mentioned earlier, you can apply for select access. I have no doubt that there's some people watching here will probably be a great fit based on what you've been sharing in the community, on the forums, on Discord. So I encourage everyone to apply who thinks they might have something to offer. Does anyone have any last comments or anything else on the panel that you wanted to share? Maybe we missed it a little earlier. Lior, I have to say, I feel like you and I are very, very lucky on the NVIDIA team, because while all of our engineers are very hard at work on the platform, you and I get to really get to know some of these great people across the world leveraging this technology.
Exactly. Yes. I mean, this is so exciting, seeing like the stuff that I'm talking about like every day being realized, and thinking about like the potential of such a things, in the right hands. This is really great.
It's fantastic. I can't thank you all each enough, and also for putting such great material together to show off to the community and sharing all this knowledge. And the demo was fantastic. Lars and Paul, thank you. Christian, it was really great to hear about the story of Wandelbots and where you guys are going. And Maureen, thank you about sharing everything about OpenUSD. And the work of your team is just super compelling. I want to thank each of you for sharing this on the OpenUSD Insider Series today. Now, exactly in 9 minutes from now, if you're watching this live, is the Isaac Sim Isaac Lab study group, which is being hosted by Scott Dempsey from the community. That's on the NVIDIA Omniverse Discord server. So if you if this is not enough and you need more, come to the study group. You can chat with some other users. Who knows? Maybe some of the panel will jump in there. But we also created a thread on this live stream afterwards. I want to thank everybody for watching. All the great comments, the great questions have been really helpful this whole hour to everyone, or more than an hour for everyone on the stream. Thank you for all staying a little longer to cover some of these questions. Really fantastic. And I'm really excited to see what comes next. Congratulations on this huge milestone, Wandelbots team. And as you get ready for wider release, I can't wait to see some of the stories that come out of what people are able to do with the increased access to robotics that you guys are making available to everybody. So, I think the big takeaway too also is that how it's robot agnostic, which is simply like amazing. So thank you all for sharing this great work. We look forward to what comes up next from you guys.
And thanks for having us. So
Yes.
was a great journey with you guys so far, and there is a lot more to come in the future.
I can't wait.
Absolutely.
All right. Until next time, thank you for joining us. Check our event calendar for the next live streams and other events that are coming up, including that study group that starts in 8 minutes. So I got to get a drink of water before that happens. Okay. Thanks, everybody. I'll see you soon.
Thanks, everyone. Thanks, Edmar.
Thank
Bye.
you, everyone.
Thank you very much.
Bye-bye.